Okay, our next topic is dealing with radicals. We begin here in this video just kind of introducing the idea of radicals. So the most common radical that most people are familiar with is the square root. But in fact, anything that involves that little symbol is known as a radical. Even if we have like a little number in front like 3, that would be called the third root. We'll talk about that in a moment. Those are all called radicals. The square root is just asking what number squared, or in other words, what number raised to the second power would give us x. As an example, consider the square root of 9. Most people would see square root of 9 and immediately say, oh, it's got to be 3. Why is it 3? Because if you took 3 times 3, you would get 9. But hold on to that idea for just 1 second, though. If you took negative 3 times negative 3, you'd also get 9. So is the square root of 9 equal to negative 3? No, it's not. Because when we take the square root, when we write square root of a number, we're asking for what's known as the principal or the positive root. So when we write square root of x, we're always looking for the positive answer. And so square root of 9 is in fact 3, even though negative 3 times negative 3 will also give you 9. When we write square root, we're looking for that positive root, looking for that positive answer, which is called the principal root. As another example, what if we said, let's do square root of negative 4. What number would you multiply times itself to get negative 4? And so you might want to think about that for a moment. Well, I can certainly say that it can't be a positive number, right? Because if I took a positive number times itself, then that would give me a positive number. Because positive times a positive is a positive. But wait a moment, it can't be negative either. Because if I took a negative number times itself, 2 negatives make a positive when we multiply. So if it can't be positive, it can't be negative, what's left? Well, the only thing left in our world of numbers as we currently understand them is 0, but 0 times 0 is 0, not negative 4. So we've eliminated every possibility, and so therefore we'd say it's not real. It's not a number as we currently understand numbers. And people were quite content with that. In fact, that's probably where our name real numbers come from, is because then there's these other things that don't behave like people think numbers should. We're going to address that a little more thoroughly in a later section. For now, we will be satisfied with saying that that's not real. Okay, so we move on. If we put a little number in front of the radical symbol, then that's talking about something other than a square root. When we put a little 3 there, that's read as a cube root or third root. And it wants to know what number raised to the third power would give you x. As an example, consider the cube root or third root of 64. What number would you multiply times itself 3 times to get 64? Well, it turns out the answer is 4, because if you took 4 times 4 times 4, or 4 to the third power, you would get 64. Now with the square roots, we had an issue with a negative number. Will we have that same problem with cube roots? Well, the answer turns out to be no, because cube root wants you to multiply it times itself 3 times. And so if you multiplied negative 2 times itself 3 times, you actually can get a negative answer. So square roots, in fact, any even root in general, right now we can't do it for a negative number. But for third roots or any odd root, since when you multiply something an odd number of times you can get a negative, they're okay. So the cube root of negative 8 is actually negative 2. In general, when we write a number in front of that radical symbol, that wants to know what number raised to the nth power, whatever the number happens to be. Now it does have to be a counting number, 1, 2, 3, 4, 5, 6, 7, and so on, for it to make sense. We want to know what number raised to that power is equal to x. As another example, consider the fourth root of 81. That would be equal to 3, because if you took 3 times itself 4 times, you actually will get 81. Or we could say, what's the fifth root of negative 32? What number would I multiply times itself 5 times to get negative 32? And the answer is negative 2. One final example, let's consider the fourth root of negative 81. For exactly the same reasons that we could not do the square root of negative 4, we cannot do the fourth root of negative 81 right now. Because if you multiplied something times itself 4 times, it's going to have to be positive using numbers as we currently understand them. Now, it's going to turn out later on in this unit we will learn how to simplify square roots of negative numbers, but it takes a lot more mathematics to be able to compute a fourth root of a negative number. That's still quite a ways off. You need a good bit of trig and stuff before you can do that. So this is just an introduction to radicals. In upcoming videos we are going to look at simplifying radicals with both numbers and variable expressions. Until then,